Hi students, in last class we discussed classification of elements based on differentiating electron and classification of elements based on properties. In this class we will discuss about metals and non-metals, metalloids, and also we will discuss about valency. Here we can see periodic table. Elements which are shown in brown color are metals. Elements which are shown in gold color are non-metals. And elements which are shown in light blue color are metalloids. Now we will discuss one by one in detail. First of all, we will discuss about metals and non-metals. The elements with 3 or less electrons in the outer shell are considered to be metals. Elements which having 3 electrons or less than 3 electrons in the outer shell are considered to be metals. For example, first A group elements having 1 valency electron in the outer shell. Second A group elements having 2 valency electrons in the outer shell. And third A group elements having 3 valency electrons in the outer shell. So, first A group elements, second A group elements, and third A group elements. They are the metals. And those with 5 or more electrons in their outer shell are considered to be non-metals. Those with 5 or more electrons. If you observe 50A group elements, they contain 5 electrons in the outer shell. 60A group elements contain 6 valency electrons. 70A group elements contain 7 valency electrons. And 0 group elements contain 8 valency electrons. So, they are considered as non-metals. We may find some exception to this. However, we may find some exceptions to this. D block elements. Already we know D block elements. From 3rd group to 12th group are metals, and they are also known as transition metals. And the metallic character of D block elements decreases gradually from left to right in the periodic table. D block elements are the metals. They are also known as transition metals. Already we discussed. And the metallic character of D block elements decreases gradually from left to right in the periodic table. Metalloids or semi-metals are elements which have properties that are intermediate between the properties of metals and non-metals. Metalloids are semi-metals. Both are same. They are the elements which have properties in between the properties of metals and non-metals. They possess properties like metals but brittle like non-metals. Metalloids having properties like metals, some properties like metals, and they are brittle like non-metals. They are generally semiconductors. They are not good conductor, they are not bad conductor, they are the semiconductors. Example for metalloids are boron, silicon, arsenic, germanium. Boron, silicon, arsenic, germanium. Those are the metalloids or semi-metals. All elements in S block are metals. All the S block elements are metals. Whereas in P block, already we discussed, in P block there are some metals, some non-metals, and few metalloids. In the periodic table, you will notice a staircase-like separation. Here we can see periodic table. If you observe the elements which are in green color. It is like a staircase. Boron, silicon, germanium, arsenic, antimony, tellurium, polonium. This separation is like a staircase. And which are left to the staircase all are the metals. Which are right to the staircase all are the non-metals. All the S block elements are metals. All the D block elements are metals. All the A block elements also metals. But if you observe P block elements, there are some metals, some non-metals and few metalloids like boron, silicon, germanium, arsenic, antimony, tellurium, polonium. These are the metalloids. The elements to the left of this separation or staircase are the metals and to the right are non-metals. The elements on staircase are very near to it like boron, silicon, arsenic, germanium are metalloids. Elements which are very close to staircase are the metalloids. Now we will discuss about valence or valency. The valence or valency of an element was defined as the combining power of an element. Valency is nothing but combining power of an element with respect to hydrogen, oxygen or indirectly any other element through hydrogen and oxygen. Valence or valency is nothing but combining power of the element with respect to hydrogen or oxygen or indirectly any other element through hydrogen and oxygen. Valence of an element with respect to hydrogen is the number of hydrogen atoms with which one atom of that element chemically combines. Valence of an element with respect to hydrogen is the number of hydrogen atoms. For example, here you can see methane. Methane formula CH4. So, with carbon 4 hydrogens can form bond. So, carbon valency is 4. Valency is nothing but number of hydrogen atoms. If you observe ammonia formula NH3. With nitrogen, 3 hydrogens are bonded. So, nitrogen valency is 3. If you observe water molecule H2O, with oxygen, 2 hydrogens are bonded. So, oxygen valency is 2. So, what we can say? Valence of an element with respect to hydrogen is the number of hydrogen atom with which one atom of that element chemically combines. We will see another definition. Valence of an element with respect to oxygen is the twice the number of oxygen atoms with which one atom of that element combines. If it is oxygen, twice the number of oxygen atoms. For example, if you observe carbon dioxide formula CO2. With carbon, 2 oxygens are bonded. So, we have to take twice the number of oxygen atoms. 2 carbons are bonded, twice the number of oxygen atoms is 2 into 2, 4. So, carbon valency is 4. Magnesium oxide. With 1 magnesium, 1 oxygen is bonded. So, magnesium valency is 2, twice the number of oxygen atoms. If you consider hydrogen, number of hydrogens bonded is valency. If you consider oxygen, twice the number of oxygen atoms bonded will give the valence. In general, the valence of an element with respect to hydrogen is the traditional group number. In general, valence of an element with respect to hydrogen is the traditional group number. That means the valence of first year group elements is 1 and valence of second year group elements is 2 Valence of third A group elements is 3. Valence of fourth A group elements is 4. When we are considering group 1 to group 4, then valence of an element with respect to hydrogen is traditional group number. If the element is in the group 5 or above, then its valence is 8 minus group number. The element is in group 5 or above, then valence is 8 minus group number. For example, if the element is in 6th A group, then valence is equal 8 minus 6, 2. If the element is in 7th A group, then valence is equal 8 minus 7 is equal 1. If the element is in 0 group or 8th A group, then valence is equal 8 minus 8, 0. For example, chlorine valence is, chlorine belongs to 7th A group. So 8 minus 7 is equal 1. The group number of an element gives the maximum valence of that element as per old notation. That is group 1 to group 8. But it is 1 to 18 group number as per IUPAC numbering. According to old notation, we are giving the number from group 1 to group 8. So group number gives the maximum valence. But according to IUPAC numbering, we are giving numbering from 1 to 18. Here already you know this table. First A group elements having one valency electron, so their valence is 1. Second A group elements having two valency electrons, their valence is 2. Third A group elements having 3 valency electrons, their valence is 3. Fourth A group elements having 4 valency electrons, their valence is 4. Now fifth A group elements having 5 valency electrons, their valence is 8 minus 5, that is equal 3. Sixth A group elements having 6 valency electrons, so their valence is 8 minus 6, 2. Seventh A group elements having 7 valency electrons, so their valence is 8 minus 7, 1. Eighth A group elements having 8 valency electrons, so their valence is 8 minus 8, 0. In general, each period starts with valency 1 for first A group elements, increases up to 4 with respect to group number, and then decreases from 4 to 3, 3 to 2, 2 to 1, and 1 to 0 in the following groups. From first A to fourth A, valence increase from 1 to 4, and fourth A to 8th group. Valence decreases from 4 to 3, 3 to 2, 2 to 1, 1 to 0. This is applicable only for main group elements, that is S and P block elements with respect to hydrogen. We are considering only S and P block elements, valencies. Nowadays, the valency of an element is generally taken as the number of valency cell electrons in its atom. Nowadays, valence of an element is taken as number of valency cell electrons in the atom. So, this is about valency.